Let's talk about bias and variability in a sample. It's going to rain for several days, and I'm worried about my property flooding. So I go to a place that has sandbags. They have tons and tons and tons of sandbags. Now I'm going to load up my truck. They say that the sandbags are 40 pounds each. Well, I load up my truck and I realize that, you know what? They're not 40 pounds each. Some of them are really light and some of them are really heavy. That means it has high variability. I go to a different sandbag place. They're all pretty close to 40 pounds. That would be low variability. How much it varies in your sample. Now, bias is, are they on target or are they off target? Meaning, if they said they're 40 pounds and they're all right around 40 pounds, that's low bias because they are what they said they are. High bias would be, let's say I go to a different sandbag place and they're all 60 pounds, really heavy. So they're off target. Okay, speaking of targets, let's look at it this way. Let's just say I get 10 sandbags in a sample. Now here's my first one. It looks kind of like this. 3, 4, 5, 6, 7, 8, 9, 10. So, what about the variability? Well, the variability is very low because they're all clustered together. What about the bias? Well, they're right on target. So this is low variability and low bias. So that's a really good sample. All the bags were right around 40 pounds. Let's look at another one. How about something like this? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, still low variability. Okay, they're all clustered together. They're all right about the same amount, except they were wrong. Okay, so they're all about the same wrong amount. That's low variability but high bias. Okay, let's look at another one. How about this? 4, 5, 6, 7, 8, 9, 10. Now, they're all over the place, but if you think about where are they centered, it looks like they're centered right around here. Okay? So, high variability, right, because they're all over the place. High variability but low bias because they're still going to end up in that center if you took the average. And then our last one would look something like this. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, high variability because they're kind of all over the place, but also high bias because the center of this grouping looks like it's right around here. Okay, so it's off target. So you got two different things to think about. Bias and variability. Is it high or is it low? Okay. Let's think about a distribution of our sample data, meaning we take many samples. 4 different places, they all say that their sandbags are 40 pounds. Okay. So let's look at this first one. Okay. So the spread of this graph is not very wide. Okay, so it's got a small standard deviation. So we would say that this has a low variability, but it has a high bias because it is off target. They say it's 40, but they're a lot lighter. Okay, let's see. One more time. Low variability, but high bias. Okay, that's the first one. Well, look at the second one. Can you guess what this is? Well, it's got low bias because we're centered at 40, but it's got high variability because the spread of the graph is very wide. We had a lot of low samples and a lot of high samples. They weren't all really close to 40. Okay, so that is high variability, low bias. So this one, it looks like it's high variability because it's got a bigger spread here, the graph is spread out, and a high bias because they're off target. And then you have this last one, which would be low variability because they're all centered right around 40, and low bias because it's right there. So this would be a good one, I would think, because all the sandbags were right around 40 pounds. Okay, so that's variability and bias. Now there's a couple of other things. They call something an unbiased estimator if the parameter, the thing that you're kind of assuming is true, right? 40 pounds, if it's actually true. So this would be an unbiased estimator because your average is actually 40. Okay, you're on target. And you try to do things where you have an unbiased estimator, where you're on target. Your parameter is going to be the same as what your sample is. Okay, unbiased estimator. And then there's another thing called a sampling distribution. The sampling distribution is a distribution that shows every single possible situation that you could have for your sample. Okay? Now that's a sampling distribution. Don't get that confused with your distribution of your sample data. Those are two different things. Here's a distribution of our sample data, okay? But it doesn't show every single possible situation we could have, okay? That's a sampling distribution. Now, anyway, that's it for section 7.1, and I'm going to give you some questions when we see each other in class. Okay, bye.